You've definitely heard the term polar vortex, right? It usually pops up in the news when it's being blamed for burying a city in a mountain of snow. It sounds like some kind of, I don't know, a monster storm, a terrifying new force of nature. But the truth? Well, it's way more interesting than that. What if I told you it's not a storm at all, but this permanent, invisible giant that's always spinning at the very top of our world? Let's really get into the science behind those bone-chilling headlines. So, to really get a feel for the kind of impact this giant can have, let's rewind to a pretty powerful example. Picture this. It's late January 2026. A massive winter storm, which got the nickname Fern, is just carving this path of destruction right across North America, bringing pretty much the whole country to a standstill. And look, this was so much more than just a snow day. The storm's toll was just devastating. It was blamed for at least 50 deaths, from things like hypothermia to, just incredibly dangerous road conditions. We're talking about a life-threatening event on a massive scale. And when I say massive, I mean it. The scale was just staggering. At its peak, more than 220 million people were under extreme cold warnings. That's nearly 2/3 of the entire U.S. population. From the northern plains all the way down to Texas, record-breaking low temperatures just had the nation in their grip. So that brings us to the really big question. An event of this size doesn't just happen by chance. What's the atmospheric engine that's driving these super intense, widespread deep freezes? Well, the answer isn't a storm, but something much, much bigger. So let's finally meet the phenomenon that's at the heart of our story. While the news often points to the polar vortex like it's the storm itself, the reality is way more fascinating. It's kind of like the hidden culprit, pulling the strings from way up high. So what exactly is this hidden culprit? Well, the polar vortex is this huge, persistent cyclone of incredibly cold air that's always spinning around the poles, miles and miles above the weather we actually feel down here. The best way to picture it? Think of a giant atmospheric whirlpool, just sitting right there at the top of the world. And this is maybe the most important thing to get straight. The polar vortex is not a storm. It doesn't just pop up out of nowhere. It's a totally normal, permanent part of our planet's climate system. It's always there, just getting stronger in the winter and then weakening in the summer. It also gets mixed up with another one of those media buzzwords, the bomb cyclone. But they are completely different things. A bomb cyclone is a powerful, fast-growing storm that happens down here on the surface. The polar vortex, on the other hand, is the massive system way up high that basically sets the stage for that extreme cold, creating the perfect conditions for those surface storms to get going. Okay, so here's where it gets a little weird. The real danger isn't a strong polar vortex, it's a weak one. Yeah, you heard that right. When this giant system gets disturbed, it becomes unpredictable, and that's when things start to get interesting for us down below. Think of a healthy, strong polar vortex as a kind of celestial fence. When it's stable and spinning fast, its powerful winds act like a perfect barrier, containing all of the planet's absolute coldest air and just locking it right over the Arctic where it belongs. But sometimes that fence can break. You see, large waves of atmospheric energy can push up from below and literally slam into the vortex, knocking it off balance. This disruption can cause something called a sudden stratospheric warming, which is basically what it sounds like. The air way, way up above the pole heats up really fast. This warming event weakens the vortex, and it starts to wobble or stretch or even split into pieces. And here is the key connection for us. A wobbly vortex high up in the stratosphere leads directly to a wobbly jet stream down below. That river of air, which normally flows in a pretty straight line, starts to buckle and form these deep waves. And those deep dips that swing southward, they become the perfect escape route for all that trapped Arctic air to just spill out. When the vortex gets weak, it doesn't just wobble. It can actually break apart. So instead of one solid spinning center of cold, it might split into 2 or 3 different lobes. And as you can see here, these lobes of freezing air can then just wander south, bringing those brutal cold snaps to places like North America, Europe, and Siberia. So this all leads to a much bigger question, doesn't it? Are these disruptions, these breakdowns of the vortex, happening more often now? To even begin to find the answer, we have to look north at the huge changes that are happening in the Arctic. This is a phenomenon known as Arctic amplification. And honestly, the numbers are pretty wild.
The Arctic is warming up almost 4 times faster than the rest of the globe on average. This rapid warming is shrinking the temperature difference between the poles and the tropics. And that very temperature difference is the engine that drives a strong, stable polar vortex.
So, does that mean climate change is making the polar vortex more unstable? Well, the answer is it's complicated. As this slide kind of shows, this is a subject of really intense scientific debate right now. Some studies suggest there's a pretty clear link. A warmer Arctic means a weaker, wavier jet stream, which makes these cold outbreaks more common. But other studies argue that, while the idea makes sense, natural atmospheric changes are still the main driver, and we just don't have enough data yet to prove a definitive trend. Okay, so after all of that, what's the verdict here? What should we take away from all this? Let's just boil it down and see what this all means for the future of our weather. Here are the big things to remember. First, the polar vortex is a totally normal, permanent feature way up in the stratosphere. It is not a storm on the ground. Second, the danger comes from a weak or disrupted vortex, because that's what allows that frigid Arctic air to spill south. And finally, the possible connection between a warming Arctic and more of these disruptions is a super important ongoing area of scientific research. And that leaves us with a pretty critical question for the future, doesn't it? While scientists keep working to figure out the exact connections, one thing is absolutely certain. The Arctic is changing in a profound way. So the real challenge for us is, how do we prepare for a future where the atmospheric giants that govern our weather might just become a whole lot more unpredictable?